So, welcome back to Akyas classes. Fortunately or unfortunately, we are putting a pause on the algorithms for now, maybe for 1 or maybe 2 months. So, we have so far covered 36 different algorithms. So, for now, we'll just focus on the interview questions that you may have, or you might have, or you definitely are going to have in your interview questions. So these are going to be 10 different topics which will have 10 different questions that you might encounter in your interviews. And we'll also have 4 dedicated videos on understanding how to tackle interviews. Like if you don't know the answer, then how to tackle that? If you don't know a particular topic or a concept, how to tackle that? How to say no without saying no? And how to explain that this is your expertise and this is not. All of these things we'll be going to cover into the next 14 videos. 10 different topics of their interview questions and 4 dedicated videos on tackling interviews. That is going to be our goal for next 14 days. So by the end of this 14 days, we'll be done with 50 days at DSA, and then we'll begin coding into a new series, which will be 30 days at some interesting new stuff. So we'll just do random things. Well, we'll create our own Snapchat, not particularly an application, but we'll just particularly create a simple program which will allow you to have like filters like Snapchat, where you will have masks like Snapchat, and a lot of different things like your own Google or your own Seal or something like that. So that is going to be an interesting part. But for now, we'll just focus on this 14 days to make you, to help you crack your DSA interviews. So today's topic is going to be the array and strings. So today we are diving into one of the most common topics in the interviews, arrays and string. So we'll break down two crucial techniques in this one, the two pointer technique and the sliding window technique. These are essential for solving complex problems efficiently. So all you have to do is stick around till the end, because we'll go through our popular interview questions, the two sum, step by step. So you might have seen or you might have heard about this question on the lead code. It is really famous, and even in the interview questions it is asked a lot in dozens, maybe thousands of companies who hire DSA or who ask questions about DSA. So the first thing, understanding the basic principle. So arrays and string are some of the most fundamental data structures in coding interviews. An array is a collection of items stored in a contiguous memory location, and strings are essential for string are essentially array of characters. These structures are often used to solve problems that involve searching, sorting, finding subarrays or substrings. So basically we just have an array which have multiple elements which are given in a contiguous memory location, which have memory location. So let's just say I have Akya placed on the 0th index, then I have some other name, maybe Cuckoo on the first index, maybe I have some third name, maybe I have fourth name, and all of these are given at a contiguous memory location. These are stored in a contiguous memory locations. And then there are strings. Akya is a string, Cuckoo is a string. All of these are built with an array of characters, right? So why are these so important? Because they're versatile. You can manipulate them into countless ways, and they form a very basic and many complex algorithms. So if you're comfortable with arrays and strings, you're already halfway there to solving many interview questions like this. So understanding the key techniques. So there are simply 3 key techniques to solving this particular problem. The first thing is two pointer technique. This is a great tool for problems that involves comparison between elements, especially when the array is sorted. So performing a two pointer technique involves 3 basic steps. The first is set one pointer at the start of the array and one at the end. Then the step 2 is to compare the values of both the pointers. Based on the comparison, either moves left or to the right pointer. Then you have to continue this process until the pointer meets and the condition is satisfied. Let me just give you an example. Let's say you've asked to find two numbers in a sorted array that sum up to a target. You start one pointer at the beginning and one at the end. If the sum is less than the target, move the pointer to the right. If it's more than the target, then move the pointer to the left. This reduces the time complexity from O n square to O n, which is going to be really great. Now, what do we have next is the sliding window technique. So, this technique is super handy for problems that involves subarrays or substrings. The idea here is to use a window of element and slide it across the array. This involves basic 3 steps. Start with a window that covers the portion of the array. Then gradually slide the window from left to right and adjust its size as needed. Then you have to track the necessary conditions like sum, maximum, specific element as you move the window. This technique is perfect for problems like finding the longest substring without repeating characters or finding the maximum sum of subarrays. It helps reduce the complexity by avoiding unnecessary recalculations. So we covered the 2-pointer, then we covered the sliding window technique. Now we have an string manipulation. So string manipulation is an interesting one, but let's just put it right aside for now and just focus on the question that we have to solve, because string manipulation I don't think particularly is a very good approach or very good as a technique into finding the solution to what our problem exactly is. So let me just give you the analogy of what our problem is. So our problem statements goes something really simple. Given an array of integer and a target value, right? So this must return the indices of which the two numbers such that they can add up to the target. So basically we have to assume that there is an array which have element, let's just say 2, 7, 11 and 15, and then we have a target. So target maybe can be 9 for example. So now we want an output where we'll have at most at least 2 indexes, right? At least 2 indexes which sums, when we sum up them we have the answer which we have as the target. So let's just say we have 2, we have a 7, we have an 11 and we have a 15, right? So now if I were to add any of 2 elements which can give me 9 as an answer, think about it. We have a 2, we have a 7, we have 11 and we have 5. So the answer is pretty simple. 2 and 7 equals to 9, right? So the 0th index and the first index. So nums of 0 plus nums of 1. So the answer is 2 plus 7. So the answer is going to be 9. So that's what we want from our algorithm to find out, right? So how do we do that? We have 2 basic solutions for it, right? The first is brute force approach and the second one is the optimal approach, the hash map approach. So the first, brute force approach. We can iterate through every pair of numbers and check if the sum of the target, this works, but the time complexity is O into n square, which isn't effectively for large arrays. Like you cannot use it for large arrays. It is really slow as a process. So the solution checks every pair for the numbers. For the large data sets, we need something faster, right? So there comes something else in game, which is optimal approach using the hash maps, right? So the key idea here is to store the complement of each number, which is target minus n of I, in a dictionary as we iterate through the array. So the step-by-step process is pretty simple. We have to initialize an empty hash map, then we have to loop through the array for each elements, then calculate the complement, target minus the current element, and then check if the complement already exists in the map. If it does, return the indices of the complement and the current element. If not, then add the current element to its index of the map. So the solution is much faster with a time complexity of O(n). As we go through the array only once and perform constant time lookups in the dictionary. This approach is much more efficient for large inputs. So let's just do the coding for a little bit of time and then you'll understand it more precisely once you see the practical implementation of it, right? So this is simple. All we have to do is first start with creation of a function, which is going to be obviously the two sums. But before that, we'll just create a nums and target as our array and the target. That's the first thing we are going to do. You can even do it last, because functions, when you call them, that's where they're born. So before anything that you write in the parenthesis is just a formal parameter, not an actual parameter, so it won't throw any error anyways. So we have created a complement map as an empty dictionary, as we have already talked in the further theoretical parts. Then we'll just iterate over it using the for loop for I and num, right? Now let's just use the if statements up here. If complement in complement map, if it does actually exist, then we have to just return the complement map, the complement of the complement map, comma I. And if it does not, if this condition is particularly not true, then we'll just execute the complement map. Num equals to I. Simple. Even if it is true, then eventually it is going to get executed anyways. So now we are going to print the result, pass in the number and the target, and then we want the result, right? So specifically, we want our output to be 9. No, 0 and 1, because our target is 9. So let's just see if the output is 0 and 1 or not. So as said, 0 and 1 is our output, because 7 adds 2 equals 9. And that is it. Today we have covered two powerful techniques, 2 pointers and sliding window, and solved an 2 sum problem with an optimal solution using the hash map. So this technique is the backbone of many array and string problems you'll face in interviews. So make sure to practice more problems on array and string and to strengthen your skills. In the next video, we'll dive into linked list, another core data structure of interviews. So don't forget to hit the subscribe button, give this video a thumbs up, and leave a comment below if you have any questions. Thanks for watching. See you in the next one.